3-4 minutes. Thank you. Sanjay, shall we start?
Yeah, sir. Let's.
All right. Mr. Suranga, hope you're ready with it. All right, okay, thank you. Very good evening, ladies and gentlemen. And today is our second day of mechanical CPD program. And last week we had a fruitful session from Professor Rahul Atalagi. And today we have yet another good and one of a comprehensive program lined up from one of a experienced, though he looks young, he's one of the most experienced and one of the greatest of technical designer, as well as he has vast experience. Ladies and gentlemen, for you to understand basic ground rules, I'm sure that many of you are now familiar with what we are going to do. And we have a core session, technically goes around 1.5 hours. And after that, we have a Q&A session of 30 minutes maximum. And our presenter will not be interrupted at the core session. And the chat box is not allowed for you to use until we have opened it for Q&A. And somewhere between the sessions, we have our attendance to be marked through a Google form, and that can be shared through the chat box of either Zoom or at the YouTube live streaming. For YouTube live streaming, what we recommend is all of you to subscribe and watch it, because in Zoom platform, we have a limitation up to 1,000. And those who are beyond 1,000 participants. At the same time, if you get disconnected, what we recommend is to continue with the YouTube live streaming. And even after the sessions, you can watch them and you can share with your friends and colleagues if you are interested, or if anybody who's interested. With that remark, ladies and gentlemen, thank you very much for being with us in a Sunday evening. And let me introduce today's presenter. Today, we are basically focusing on the design aspects of the air conditioning and mechanical ventilation. For that, we have, as I mentioned, this young-looking but experienced, or one of the key personnel in the industry. Many of you know, and those who are engaged with IESL know who this gentleman is. By the name, he is Engineer Suranga Lekambasam. Suranga Lekambasam graduated from University of Moratuwa, specialized in mechanical engineering, and obtained his postgraduate diploma in building services engineering. He's a chartered building services engineer involved in design and consultancy for more than 15 years. Engineer Lekambasam has been a resource person and a panel member of many professional forums and serving as a visiting lecturer for many institutes such as IESL CPDs, Centrac, City School of Architects, SLTC, and University of Moratuwa. Ladies and gentlemen, without wasting much of a time, let me invite Engineer Suranga on screen. Engineer Suranga, it's over to you.
Ladies and gentlemen, thank you, Nalin, my good friend, for introducing me. First of all, I must tell you that I am today behind a big turbulence, as you all facing, big rain, power cut is about to schedule. Despite of all this, I will try my best to deliver some of the salient and important aspects of the today's topic. Without further ado, let me pull out and share my presentation. I hope my presentation is visible to you and my voice is audible to you. With that permission.
It's all perfect, Suranga.
Well,
please.
Good. I'll move forward. Before going to the content, I must tell you that this is a vast area. We may discuss for continuous weeks, probably. But yes, with the time permits, I have selected some very important area. Again, sort of a cream of the topic. Within the time permit, I will try my best to share. Right. Well, first of all, we all must understand what is air conditioning. This may be a very layman level question to you, but I feel that is very valid for you to understand before you dig into the subject more and more. Simply, what is air conditioning? Some may say that, okay, cooling is air conditioning. I do agree, cooling is air conditioning, but cooling alone will not satisfy the definition of air conditioning. Air conditioning has many parameters which you need to maintain within the predefined period, predefined range, predefined status, right? So therefore we call air conditioning as maintaining a thermally comfortable environment, right? Thermally comfortable environment. So what is thermal comfort of a human being? Very simply, we like a machine. We work like a machine, right? We eat food and digest, produce energy, but eventually the byproduct is the heat. So our body should continuously dissipate that heat within the environment which we are living. So if you get a human being, you can see in the picture, there are many ways that the human body exchange heat with the surrounding. Probably with convection, right? You remove heat by convection, sensible portion, maybe by radiation. Yeah, that's again sensible portion. Then sweating process will dissipate heat from the body by both sensible and later, where you add moisture to your surrounding. Similarly, due to our respiration, we dump moisture, hot moisture. So we add latent as well as sensible by respiration process. Simply, if we are living in an environment which encourage or rather which facilitate this heat exchange with the human body, we feel thermally comfortable condition as a human being. So making that thermally comfortable surrounding is called air conditioning, right? That's the simple and correct definition of this topic. How do we do that? There are many parameters, as I told you, which you need to maintain within a range. Air temperature is primarily an important parameter which you need to maintain. We maintain probably 24, 22, somewhere there, as we are living in a tropical climate. Then importantly, RH, or the humidity, plays a vital role, especially countries like us where our RH, ambient RH is very, very high. So you need to drop the RH to a certain level to encourage the moisture dissipation, or rather latent heat exchange from the human body. So that is, again, you need to look at in your design to control the RH. Then equally important, air velocity, because when the air velocity which interact with your body, if it is high, your rate of heat removal is also high. Therefore, you can play a lot with this air velocity parameter. In modern society, modern industry, we are so keen on energy aspects. There is a concept called hybrid cooling. It's like this, like let's say, for an example, you are running your air conditioner, let's say at 24 degrees, right? So you feel certain level of comfort. Now, let's say now you run your air conditioner at elevated temperature, say like 27 or 28 degrees, and you switch on your ceiling fans if they are occupied, if you install ceiling fans. What they do is they will increase their velocity within this space. So if you compare the two scenarios, running the AC at 24 degrees, running the AC at elevated temperature, which save energy for sure, at little higher air velocity, you will get the same level of comfort at lower cost. So this concept is becoming very popular in state universities, maybe applicable for even local state-based institutes which are air conditioned. Without compromising the comfort, you can save energy. That is a big crisis for all of us to look at. So yeah, velocity plays a vital role. Then radiant temperature, I don't want to go into much detail on this aspect. Typically, if you maintain air temperature, RH, velocity all in order, but still if you have some radiation presence in the ambient, you are not comfortable, right? There is a radiation heat exchange happens. So you have to maintain all these parameters in range to maintain this thermally comfortable condition, right? In addition to that, there are minor aspects like clothing factor, etc., which are obviously minor. So let's again ask you a question. Now you have designed a system perfectly maintaining air temperature, velocity, humidity, and all that. You have made a thermally comfortable environment. So can you say that you have done a perfect AC design? I would say no. Why? There are few more factors to be looked at which are beyond the thermal comfort. Okay. So if you see the sample of air that you are breathing most of your lifespan, because human being, we are living maybe 80% of our lives in built environments, indoors. So we breathe indoor air. Then experimentally proven that indoor air is polluted at least 2 to 5 times than the outdoor. So you can understand the scenario. It significantly impact our health if we are continue to breathe this pollutant air. Therefore, as an air conditioning designer, you have to maintain proper IAQ level, which is known as indoor air quality. There are various ways that you can maintain this IAQ level. Let's say if you have like airborne particles like dust, smoke, hydrocarbons, etc., you can do simple filtration and remove that. But there are certain parameters which you cannot physically filter. Example, carbon dioxide. We are continue to expel carbon dioxide, and finally, the level of carbon dioxide, ppm level, is continue to increase within the ambient. So how do we control carbon dioxide? The only option is adding fresh air. So to maintain IOQ level, filtration as well as fresh air is essential you to look at. Let's say now you have complied all these things your design, and when you go into the office and start off working, if your diffusers are emitting a huge noise or nearby HUs are emitting a huge noise, can you peacefully work with the environment? Obviously no. So equally important that you have a look about the uh, acoustic aspects on your design. Maybe locating your HUs, right? Your duct design for low velocity, eliminate duct drumming, many things to be looked at. Probably your terminal selection, like diffuser selection. All this matters a lot. So you need to think all in wisely. Yeah. Uh, Moving forward, now you have designed your complete AC design. But again, I want to touch a little bit of fundamental aspects as well, which are really important for you to become an expert on HVAC. What does your air conditioner do finally? Now you install the air conditioner. What is its task? What does the AC do? Simply, it removes heat. It removes heat. Let's say now you maintain this your shown space like uh, like 24 degrees, then what will happen? Your ambient is warmer than that. So there are different modes of heat gain. I think Professor touched this certain up to a certain level on last lecture. You can get conduction heat gain through your walls, glazing, roof, floor, partitions, etc. Then your radiation heat through your glazing, right? Then your internal loads like lighting, equipment, occupants. There are many ways that the heat is infiltrated to this air conditioned space. So final task of the AC is to take this heat out and maintain the set point equilibrium temperature, isn't it? Yeah, that's the task. But then I have a very humble question to you. Is the heat gain equal to the cooling load? Cooling load is the rate of heat removal. That is again important thing which you must understand. Heat gain is not necessarily be the same as cooling load, right? If you get most of the buildings, instantaneous heat gain and instantaneous cooling load is not equal. They are different simply because of the storage effect of the building. That is called thermal mass or thermal inertia of the building. If you see the fundamental touch with time, you can see the solid line shows your cooling load, whereas your dotted line shows your heat gain. You can see the heat gain is different, cooling load is different. Therefore, you must understand very clearly when we talk with people, people say, okay, I know about CLTD calculations and all that. When we ask the concept behind CLTD, it's this, because it's not the heat gain that you need to calculate, it's the cooling load which you need to calculate. Those are different, right? That is very important. Sometimes people ask from me to submit the heat load calculation. I say no. Instead, I will submit you the cooling load calculation because that's the correct term. Those are different. That is something very important you to understand. Well, if you work it out, I have no time to go with the calculations, load calculations, etc. But for you to do a proper calculation nowadays, it is obvious to use the software tools. With that, you can get very fine and accurate figures. You can list out all the different versions of heat gain, which you can read it out. I am not going to touch with the time permit. But of course, we have to do proper cooling load calculation rather than based on thumb rules or very simple spreadsheet calculations, which are no more applicable for today's industry. Right. Now let's have a look. How do we specify your air conditioner? Right. I mostly refer to the commercial level, not to the domestic level. You have to specify certain parameters if you want to purchase an air conditioner. You have to specify the cooling load, total cooling capacity. Then sensible or latent cooling capacity. You know, there are two heat components which you need to remove from your air conditioner. Then airflow rate, of course, you can calculate if you know the room sensible heat with simple MC delta T equation, you can calculate the airflow rate. Then cooling coil condition, cooling coil air condition. That means what is the on coil condition before the coil? What's the condition? What is the off coil condition after the coil? So these parameters you need to specify. So all these things can be looked with respect to these psychometric charts. Again, I have no time to go into detail. You can see the process. This is your on coil condition. This is your off coil condition. This is enthalpy gives you the cooling capacity or the cooling coil size, right? When you dump this off coil air, chill air into your room, room heat will bring this point up to this point, right? You can see if your room sensible heat is higher, this line become more and more flat, right? Because less latent heat. If your latent heat component is high, probably your slope of the line become bigger. Sometimes it comes to a level that it doesn't touch the saturation line, 100% line. That's why you need to think of reheating to bring this point touch the room line. So all these psychometric processes you need to understand and be thorough, but very easily you can find all these figures with the psychometric process. Then in addition to that, you need to specify whether you need a DX coil or a chill water coil. What is the system that you are going to install? Design conditions. What is the indoor temperature, outdoor temperature? That you need to specify, right? Because if you are running the AC at 20 degrees versus 26 degrees, there is an impact. There is an impact. So all these need to be specified. Then the outdoor condition. In Sri Lanka, maybe 35 would be fine, but if you are putting it in Middle East, 45 will be the condition, probably. Then special treatments. Whether you install your outdoors in a very corrosive environment, closer to the sea, the fin may need special fin treatments, right? If you are rely on air cool condensers, probably your PCB need to be treated with lamination or some kind of treatment. So all these need to be looked at, right? So with that basic understanding, I'll move to the different type of systems. Before that, I was asked to brief those few slides in Sinhala. ඇත්තටම අපි කතා කරේ air conditioning system air conditioning කියන්නේ මොකක්ද කියන එක. ඒකදී අපිට maintain කරන්න තියෙනවා parameters කීපයක්. ඒවා හරි වැදගත් හැම parameter එකක්ම in range maintain කරන එක. ඊළඟට අපි කතා කරා thermal comfort වලට අමතරව air conditioning design එක තියෙනවා parameters ටිකක් තියෙනවා acoustic properties වගේ IEQ properties වගේ දේවල්. ඊළඟට air conditioner එකක ස්පෙසිෆිකේෂන් එකක් අපි ලියන්න කොහොමද මොනවාද පැරාමීටර්ස් අපි ඒකෙදි ඉන්ක්ලූඩ් කරන්න ඕනේ. ඒතර ඔය වගේ බේසික් දේවල් ටිකක් තමයි අපි මේ වෙනකන් කතා කරේ. ඉම්පෝටන්ට්ලි අපි කතා කරා හීට් ගේන් සහ කූලින් ලෝඩ් කියන දෙක අතර වෙනස. ඒ දෙක සමාන නැහැ. මොකද ස්ටෝරේජ් එෆෙක්ට් එකත් එක්ක මේ දෙක අතර වෙනසක් තියෙනවා. ඉන්ස්ටන්ටේනියස් ටයිම් එකක අපි ගත්තා. මොකද අපි කූලින් ලෝඩ් කියලා අපි කරන්නේ ඉන්ස්ටන්ටේනියස් හීට් රිමූවල් එකක් නිසා ඒක හරි වැදගත්. right? With that, now I am moving to the different systems that we are dealing with, dealing in the industry. A simplest version is the single split system, right? As we all aware, you know any air conditioning machine, starting from to very simple single split to a very complex chillers, right? Whatever the AC machine, there are 4 elements inside the machine. 4 components. That is basically the compressor, condenser, evaporator, and the expansion device. Those are the 4 elements, 4 components, which you can find in any air conditioning machine, because that's how the refrigeration cycle continues. So there also you can see here the compressor is there. When it comes to single speed level applications, nowadays we are having rotary compressors, right? You can see how the rotary compressor operates. It has an eccentric rotor, which is driven by a motor. So you can see due to the eccentricity, you can do some compression of the refrigerant gas. So then you have the condenser, then you have the expansion device, can be capillary tube or electronic expansion valve or whatever it is. Then you have your evaporator known as the indoor unit. Then the cycle continues. So this is the very simplest version, which everyone can simply understand. Then on top of that, we have a system called multi-speed system. These are very popular in apartment buildings, vertical buildings, because when you have apartments, you may need multiple indoors. There is no space for you to locate multiple outdoors because the footprint is pretty expensive when you go higher and higher. The choice was to go for multi-speed system where you can connect multiple indoors with a single outdoor condenser, right? So that is very popular in apartment buildings and proven in the industry for last couple of years. It looks like this. You can see this is your condenser connected with multiple indoors. Special features, you can see there are different ref lines, refrigerant pipes, supply return. You have to lay separately for each and every indoor unit. That is because all your expansion devices are at the condenser unit, right? So you need to run bunch of ref pipes. But again, you can see when you feed multiple indoors with a single compressor, compressor should vary the supply cooling capacity as per the demand because I should be able to run only single unit. So then eventually your compressor has to run on an inverter. That means compressor should run on variable speed, right? That is called inverter technology. That can be applied even for single speed, which is very efficient system in terms of energy. Yeah. Very simple introduction of this. You can see the green line shows if you go for on-off type control of an air conditioner, right? Where you can't get proper set point because you need a deadband to operate any thermostat or a controller. So when you switch on and switch off the compressor in non-inverter type compressors, your set point is slightly move up and down. So you compromise a bit of thermal comfort as well as you are limiting your lifespan of your small compressor because you go multiple switching. Again, energy efficiency is not good. Instead, if you run it for an inverter, where you load and unload the compressor according to the cooling demand, you can see your deadband is now narrowed. So your comfort level is much better. As well as, this is something very important, inverter technology gives you much better efficiency simply because when the compressor runs in different speeds, mostly the compressor runs in its efficient range, probably 70 to 90% in that range. So any compressor is efficient, much efficient in that range. So that is why you can claim much better energy efficiency in inverter technology, right? So there are negative sides as well because some of the employers are specifying not to quote inverters probably. That may be with a very bad experience because all these frequency controllers, they are actually power electronics. The circuit boards are located in the outdoor unit. So if you are living in a corrosive and polluted environment, the PCBs get issues. And if you want to replace that, probably 1/3 of the cost you'll have to spend again. Therefore, some of the clients are not willing to go for inverter technology. But overall, especially in terms of energy, they are the best, right? Well, on top of that, we have the system called VRF system. People call it as VRV also, but correct term is VRF, variable refrigerant flow systems. There you can see, again, you have a single condenser unit. can be connected to multiple windows. Similar to previous system, but you can go for bigger capacity in VRF system compared to the multi-split, right? That is the benefit. So you can see here you have to lay only one set of pipes. You don't need to run one and each separate pipes for the indoor units, because here the technology is different, where your expansion devices are inside the indoor unit, right? That's the difference. That's why you can run single set of pipes to each and every unit. This is again a very commonly used system in the industry. Some of the clients are not willing again to have VRF, right? It's strange sometimes. I have some experience with very leading hotel operator. They said that they don't need VRF because your expansion device is within your indoor, and they may give some expansion noises, right? The clients are customers are complaining. So that kind of things are also there, but typically that is a good system for you to practice. VRF systems mainly they are using a compressor called scroll compressor, right? The scroll compressors are varying the speed, and thereby you can vary the cooling demand in your VRF system. So this is basically air-cooled VRF that is common even in Sri Lanka. But over to that, you can find water-cooled VRF systems as well. Yeah, not much common in Sri Lanka. I think only 5-6 maximum installations are done here. But something good to look at for small scale applications if you cannot go for chill water system. They are basically, you have the water cool condensers, because the condenser is cooled by water, similar to like water cool packages. Then you need to have your condenser water circuit similar to normal water cool systems. They are really efficient because, you know, any system, when you compare air cool versus water cool systems are much better in efficiency, because you can recall your fundamental pH diagram. When it is water cooled, your condenser operating temperature is low than air cooled, and therefore your compressor lift is less, so your COP increase. In this particular system, they have in condenser side, they have a heat exchanger, which is actually a plate heat exchanger, right? When you have a plate heat exchanger, you know they are really vulnerable for the water quality. Plate heat exchangers are very much vulnerable to the water quality. Therefore, manufacturers are demanding that you should have a closed condenser water circuit. You cannot run on a cooling tower system, because cooling tower is an open circuit which water quality is somewhat tolerable. Therefore, they ask to go for a closed type cooling system, cooling tower system, that adds a lot of cost, operational costs, design issues, etc. Therefore, I think that would be the reason why this is not commonly used in Sri Lanka. It looks like this. If you want to go for a closed circuit, you can see this is your condenser loop. The condenser water is cooled by a separate cooling tower circuit that is called a closed loop system for condenser water. But again, the system efficiency is somewhat compromised, because if you produce, let's say, 30 degrees condenser water, then your the condenser circuit may be little higher than that. So that will somewhat compromise the efficiency. But yes, you can think of installing also. This has been addressed by some manufacturers, and they have gone for a sort of shell and coil heat exchanger instead of plate heat exchanger now, and trying to go with an open cooling tower circuit, right? So this is another option which you can look at. Well, then you can find water cooled packages in the industry. If you go to your food cities or small scale shopping malls, most of them are rely on water cooled packages. There you can see you see the package unit here, which has both your evaporator and the condenser. Condenser is cooled by your cooling tower water. So you need to have your cooling tower and the condenser water pump to circulate this cooling water, or rather the condenser water to the circuit. Right, so that's mainly about the water cool system. For anyone interested, I have given you the circuit diagram in right side. You can see they have actually a good heat exchanger known as tube-in-tube heat exchanger, which is fairly good heat exchanger. That is good, I mean, rather than rely on air-cooled systems, try to go for water-cooled system because your overall efficiency improves. Well, then we have the chill water system. Okay, you can find the chill water systems in the industry. The first one I want to touch is the air-cooled chill water system, not common in Sri Lanka, but you can find many or 99% installations in Middle East if you are working with, because they don't have water. Instead, they have oil. So energy is not a problem for them. Efficiency is not a matter. So air-cooled chillers are very popular there, but not here, because we have an issue with energy, but we can tolerate the water availability. So if I simply explain, you can see the compressor here. You have the air-cooled condenser. Then you have the expansion device. Finally, you have a shell and tube heat exchanger. You can see now this evaporator cools not air like previous. It cools water, and you produce chill water and circulate that chill water throughout the building to your piping network. And there at the end, you have to install your end equipment like fan coils or air handlers. Then they will do the cooling of air as per your requirement. So that's how the air-cooled chillers are working. They are less in efficiency because any air-cooled devices, air-cooled machine is low in efficiency, as you all aware. Therefore, that is not much common in Sri Lanka. But there are some applications, if you look carefully, where you cannot use water-cooled chillers. If in the area, if you have a water shortage, or else if you have bad water quality, then this will be a choice. Again, especially if you see the hospital kind of applications, in some of the hospital design guides, they are recommending you to go for air-cooled chillers, not going for water-cooled chillers, because when you go for water-cooled chillers, at the cooling tower, there is a risk of Legionella formation, right? That can be airborne and not advisable in hospital environment because people are really vulnerable. They can get some issues due to the Legionella. Therefore, some of the hospital design guides, they are referring or recommending this. Other than that, I don't see any requirement of going for air-cooled chillers in Sri Lanka, because they eat energy, right? They waste energy a lot. Then what is the option? Sorry. Yeah, we can go for water-cooled chillers. We can go for water-cooled chillers. So water-cooled chill water systems work perfectly in our ambient. So you can see when you refer the diagram, this has basically 3 circuits. Within the chiller, you run your refrigeration cycle. Then this side you have your chill water cycle, or rather chill water circuit. Chill water circuit is a closed loop, right? It's a closed loop. Your ref cycle is also a closed loop. In addition to that, in the condenser side, you have your cooling tower. That is the open circuit, right? So you have to remember there are 3 circuits which you need to maintain properly. So this is how it looks like in different picture. So now regarding the chillers, I am happy to share some of the informations about the compressor, because compressor is the heart or the brain of the chill water system. Typically, the type of the compressor varies depending on your chiller capacity. Okay. So let's say if you want to find a chiller somewhere less than 100 ton, very rare situation. But if you want in that range, you will find the chillers with scroll compressors, right? But if you want to find a chiller in range like 100 to 500 ton, you have to you can find the chiller in with screw compressors, screw chillers. So if you see our local installations, we don't have much bigger buildings. Our all the chiller capacities are uh, in the range of like 100 to 500. So I would say 80% of our chillers installed are screw chillers. Okay. So you can see you can find single screw chillers, or some manufacturing twin screw chillers. Whatever it is, the concept is the same, right? Then you need to understand how do we load and unload these chillers, because your cooling load varies. Accordingly, you need to load and unload your chiller. The best way is to load and unload the chiller by varying its speed. That's obvious, right? You can install a VFD with your motor where it drives your compressor at variable speed. So without any issue, you can load and unload your compressor. But these are big machines, right? Sometimes your motor capacity is exceeding 100 kilowatt. So always, if you make a choice of going for VFD, your initial cost may be high. Again, when you have a bigger VFD drive, that adds a lot of harmonics to the system. Probably you may have to go for a harmonic filter itself. So things are complex. If you only concentrate on VFD loading and unloading, therefore there is another option. For screw chillers, you can go for stepless control. That means loading and unloading continuously within the range from 100 to maybe like 20% with the use of slide valves. So many of the chillers which are non-VFD, they are working on the slide valve principle, right? Movement of the slide valve will make the compression ratio so that you will get different refrigerant flow through the compressor. Well, on top of that, you have the centrifugal chillers. You can find centrifugal chillers if you are exceeding the capacity like 500 ton. These are bigger machines. There is a big difference between all the compressors we discussed so far with the centrifugal compressor, because other all compressors we discussed like screw compressor, scroll, rotary, all are called positive displacement machines. When they run, there must be a flow. But instead here, this is a centrifugal machine, similar to your centrifugal pump. You can run the pump for a shorter period without any flow, forcing the discharge. So this is a rotodynamic machine, not a positive displacement machine. That has some negativity also, because you may have heard chiller surging, which happens in centrifugal chillers. That is because this is a centrifugal machine. So they are very efficient. You can find at very big capacities, somewhere like about 500 ton. The beauty, or rather the uniqueness of centrifugal chiller is they are giving a good efficiency closer to 100%, probably above 80%. They are very good in efficiency, not much good in part load efficiencies. Whereas scroll and screw, they are much better in part load in terms of efficiency. So you have to understand, when you select the machines, you have to think all these parameters. Okay. So how do we load and unload the centrifugal chillers? Yes, the option is there for you to install a VFD driver and do the loading and unloading. That is possible. But instead of that, if you go for non-VFD chiller, you can rely on this inlet guide vanes. So inlet guide vanes you can use. It's kind of a throttle in action. You can use to achieve stepless capacity controlling of the centrifugal chiller. Okay, so but of course, efficiency wise, when you compare variable speed driver with inlet guide vanes versus inlet guide vanes only, you can see the efficiency is much better in the first option, VFD plus inlet guide vanes. Efficiency bit compromise if you only rely on inlet guide vanes. So all the things you need to look at when you define your chiller. Well, then the compressor. Further, referring to the centrifugal compressors, we can find direct drive versus gear drive, because all the motors which are used to drive the compressors are induction motors. You know, the induction motors, the maximum RPM is 2,900 to 950 because of the slip. You can't reach 3,000. But if you want to have higher compression speeds, the option for you to go with gear drives. But if you go for gear drives, you can understand there is a loss in energy as long as you have the gears. Therefore, there will be slight compromise of the efficiency if you have a gear drive machine compared with the direct drive machines. Then most controversial member in the chillers, right? The magnetic bearing chiller. That is called maglev compressor, magnetically levitated compressor. It is nothing actually. What happened was previous all the chillers, they were having the bearings known as hydrodynamic bearings or journal bearings. They use this is the journal, this is the rotor. In between, you have a fluid layer. Due to the rotation, the fluid layer exert a vertical lift force. That is a sort of a hydrodynamic lift. But when you have that oil, it is a headache really, because you have to manage the oil. The oil gets diluted with refrigerant and goes and deposit with the heat exchangers and limit or rather reduce your heat transfer efficiency. So addressing all these issues, people invented this oil-free compressor where your shaft is floating within the magnetic field, right? You can see there are different magnetic fields which are lifting the shaft. There are position sensors to check the position real time. Likewise, there are many advanced features on these magnetic bearing chillers. In addition to that, they have improved their motor. You can see it's a permanent magnet motor. Actually, this is a synchronous motor where you can go for very high RPM. Typically, if you see the rated speed of a compressor or a magnetic bearing compressor, they run closer to 40,000 RPM, which is a very, very high speed, right? That is because they are having a synchronous permanent magnet DC motors. The other beauty is that whatever the capacity range you need to find your magnetic bearing chiller, whether it is 100 to 1000, you will have only the centrifugal compressors, because with this high RPM, you can't rely with the positive displacement machines. Therefore, the compressor is a centrifugal compressor here. Then there are a lot of advanced electronic features incorporated, which obviously improve the efficiency. So this is not a new technology, I would say. This was there for last 10 years in the industry. So this is a good machine, I would say, as long as you select wisely. So I have seen people think that this is, yes, this is good in efficiency, but if you install blindly, you can't get the expected saving. Some reference I have included here. You can see, compared with induction motor, permanent magnet synchronous motor used in the maglev chillers, you can see their efficiency doesn't drop at part loads, whereas it drastically drops in induction motors, right? So you can understand the induction motor or conventional chillers are not good in this range, whereas these are somewhat sustained in the efficiency in the low range, low capacity range. Again, I have extracted a comparison which I have involved with. This is a 1,000-ton chiller. Left one is a magnetic bearing chiller. Right one is a conventional bearing chiller. Both are centrifugal chillers. Right, you can see at 100% load, right? This gives 0.55 kilowatt per ton efficiency, whereas my conventional chiller is much better in efficiency. It gives 0.53, whereas 90%, still my conventional chiller is better. But when you go down like 80, 70, let's say 60%, 0.48 versus 0.54. Now my magnetic bearing chiller is much better. Therefore, if you study the profile and efficiency curve of two chillers, I would recommend you, if you have a varying load in your building, there is no choice to better go with magnetic bearing chillers because they are very efficient in part loads. So you get the benefit. But if you have a flat load, mostly like in garment factories, their loads are mostly flat because their cooling load is derived mainly with the internal loads, machine loads, occupancy loads, etc. So no point of installing by spending much more capex because these are very expensive machines, right? If the building runs or the machine runs more closer to 100%, because you don't get much saving. Even if you get a saving, it is not substantial. Therefore, you have to wisely select these machines according to your requirement. So that is the challenge for the consultant or the designer rather than bringing the things blindly. Right. So with that introduction, I'll move to Sinhala. අපි ඇත්තටම කතා කරේ type of compressors and type of chillers. So අපිට පටන් ගනිද්දි scroll chillers තියෙනවා, පොඩි capacity වල, moderate capacity වල අපිට screw chillers හොයාගන්න පුළුවන්. ලොකු capacity වල අපිට centrifugal chillers හොයාගන්න පුළුවන්. එහෙම එනකොට අන්තිමට අපිට හම්බ වෙනවා magnetic bearing chillers. magnetic bearing chiller කියන්නේ ඒකේ bearings ඔක්කොම magnets තියෙන්නේ. ඒ magnet එකේ magnetic force එකෙන් තමයි shaft එක lift වෙලා තියෙන්නේ. ඒතර frictional forces, oil requirements මුකුත් නැහැ. ඒ නිසා මේක ගොඩක් efficient. ඊට අමතරව එයා use කරන motor එක වෙනස්. ඒ motor එක ඒ නිසා ගොඩක් part load වලදී efficient. අපි use කරන induction motors වලට වඩා. හැබැයි ගොඩක් හොඳයි magnetic bearing chillers අපිට use කරන්න part load තියෙන buildings වල. flat loads තියෙන buildings වලට මේකේ ලොකු benefit එකක් අපිට ගන්න බෑ. Right? So we were talking about that in very simple summary. Then I wanted to highlight the importance of refrigerant, right? Refrigerants are man-made substances. Simply, I can categorize the refrigerant into two streams. I am touching the chillers, right? In chill water applications, you can find chillers with positive pressure refrigerant and negative pressure refrigerant. What do you mean by that? Let's say if you select the most commonly used refrigerant R134A, they are condenser and evaporator. Condenser and evaporator, because if you get the chiller, it operates in two pressures, right? Evaporator pressure and the condenser pressure. So both the pressures are higher than the ambient pressure. You can see the curve shows this is my ambient. It's higher than both the operating pressures. So what happens if there is a leak on your heat exchanger? The refrigerant moves out. You can smell the refrigerant. But negative pressure refrigerant chillers are basically, they are still the condenser operate at positive pressure, but your evaporator operates at negative pressure compared to the ambient. You can see your evaporator operates at negative pressure compared to the ambient. So what happens if there is a leak in your heat exchanger? There will be some air, ambient air goes into the heat exchanger and making big troubles, because then our air has a lot of moisture become liquid become ice sometime. They goes and block in your, probably in your expansion devices, there are issues. So if you go for negative pressure chillers, purging systems are essential, right? There are common chillers in the industry in centrifugal range, use R123, right? So there has to be a sort of a purging system. for you to look at this issue. Then, of course, with this global impact of the refrigerant, people are now inventing new, we call it new generation refrigerants. Instead of R134A, they are having high potential for greenhouse effect. Therefore, this gas is being replaced with new refrigerants like 513A, 1234 is a D kind of. It's similar to R123 because R123 has a very high ODP value, ozone depletion potential. Therefore, by 2030, we have to eliminate this gas, right? This is a very efficient chiller. But now this manufacturer has invented new gen refrigerants like 514A, 1233ZD kind of new generation refrigerant, which will give the same level of performance as R123. So this is the advancement of refrigerant. But if you have the magnetic bearing chillers, they are obviously runs on positive pressure cycle, which use R134A. Okay. When compared with positive pressure versus negative pressure, you can see the negative pressure centrifugal chillers are little efficient, right? Little efficient than the positive pressure. One reason may be their chiller lift is very less compared to positive pressure. If you compare R123 versus R134A, 123 chiller lift is less. Therefore, they runs at low RPM. You can eliminate the gear drives. That may be one reason why they are better in efficiency, and there may be many more reasons. Then quickly, I will touch the cooling tower. That is the heat dissipating element in the system. So you supply hot water through this spreader. The water is being dripping downward through this infill, which is kind of a honeycomb structure that has made that way to increase the contact area where you blow air upward. So then you can see air and water contact. There will be certain amount of water evaporation. That evaporation latent heat is absorbed by the same amount of water, and the water collected at the basin, its temperature drops because of this evaporation. Similarly, you have to understand, because of this evaporation, there is a certain amount of water loss because of the evaporation. We call it as evaporation loss. So that this is how your cooling tower works. For you to specify the cooling tower, there are certain parameters to be looked at. Importantly, you have to specify the condenser water range. That means what's the temperature your cooling tower works. You know, in our designs, we were using 37 hot water inlets and 32 cooling tower exit. That is called range. Nowadays, we rely on 35 and 30 because of the efficiency improvements. So you have to specify that one. Then cooling tower approach, that is again very important because this approach define your cooling tower efficiency. What is the approach of the cooling tower? Approach means the cooling tower exit temperature minus your average ambient bed bulb temperature. Let's say if you run your cooling tower at 37 and 32, your ambient is 27. So 32 minus 27 is your approach. That is 5 degrees, right? So that is again, you have to specify to select the cooling tower. Then drift loss. That is again important. When you run the fan, due to the air stream, not the evaporation, but air droplets can be taken out by the air stream. This is not the evaporation, right? Evaporation happens anyway. Some water in water phase, water droplets can be taken out. That is a loss. That is called drift loss. So you have to minimize that, probably with the drift eliminators or with the construction. You have to minimize the drift loss. Typically, we say it should be less than 0.01% of the condenser water circulation. That should be in that range. Then fan power. Fan is the only element which consumes power. But again, you have to specify this because, you know, if you don't specify the fan power, what the supplier do is they will give you the very inefficient cooling tower, because Simply, fan power is basically related to the fan airflow rate and the friction loss. Friction loss means the friction loss happens for this air which is coming through the infill. So if you have a very tight infill and a small cooling tower, your friction losses are very high, and that lead to have bigger fan motor. But if you increase the cooling tower size and infill, right? So then your frictional losses are less. Eventually, your fan power absorption is also less. So unless if you specify this to minimize the cost, the supplier may give the very tight cooling tower, which consume very high amount of power. So I have done exercise actually for a given capacity of a cooling tower. I could select motors from 22 kilowatt to 7.5 kilowatt. Do you believe that? So that's a vast range. So you have to specify this. Okay, this should be the motor capacity, or at least this should be my kilowatt per ton value for my motor selection. So you have to smart, otherwise there will be issues like that. So well, then the types of cooling towers, we can find two configurations in local installations. First one you can see that is known as induced draft counterflow cooling tower, where your water goes downward and air goes upward. Heat transfer happen in line. That is called induced draft cooling towers. But over to that, you can find cross-flow cooling towers as well, where my heat transfer happen perpendicular. You can see air goes this way, water comes downward. So the contact happens perpendicularly, so the efficiency is little better compared with the counterflow cooling towers. But the problem with cross flow is that you can see just by seeing your infill is at only the periphery of the cooling tower. So you need to have bigger tower. Footprint is bigger, but efficient. Nowadays, I can see many of the people are installing cross flow cooling towers. So with that, I land onto the pumping schemes, which is again something very important. When you refer the chill water side, which is important, in industry, you can find two pumping schemes. One is called primary and secondary pumping scheme, which you can see here. There you can see two loops actually, right? You can see two loops. This is my chill water loop, chiller loop. This is my load side loop. Okay. So you know eventually, according to the load pattern, my demand varies. So my secondary pump must be a variable speed pump, right? Variable speed pump. But in this particular case, my primary pumps I have made as constant speed pumps, right? So what will happen? So in this particular loop, I have constant speed or rather constant flow rate, whereas in this loop, I have varying flow rate. So what's the balance? So you need to have a connector between these two loops to balance flow rate to bypass between primary and secondary. So this is called the decoupler, which will do the decoupling of primary side versus the secondary side. So that's mainly about primary and secondary. Why these primary pumps were constant? Actually, in old days, chiller manufacturer were not happy to vary the flow rate through the chillers. When you vary the flow rate through the heat exchanger, there can be certain things happen, right? So if just to touch something, since it is important, when you lower the flow rate, your water velocity through the tubes reduces, and that will bring you a flow type from probably transition to lamina. If you recall your fundamental Modi chart, there are three regimes there: lamina, transition, and turbulent. Typically, the best heat transfer happen when the flow is at transition range. When you reduce the temperature, it becomes laminar sometimes. Then your heat transfer is drastically dropped, and sometimes your evaporator is not transferring heat, and sometimes it lead to trip the chiller at low pressure cutoffs, so low pressure temperature. So therefore, there may be many more reasons. That is one of the key reasons they are not willing to, they were not willing to reduce that flow rate through the chiller. But nowadays, with a lot of modern controllers and advancements, they say, okay, you reduce the flow rate maximum up to like 50%, right? So therefore, I don't need this primary set of pumps because that is a waste of energy. Since it is constant flow rate, irrespective of my load side, it is a wastage. So I can eliminate all these primary pumps and I will use the single set of variable speed pumps to run the load as well as run through the chillers, because I can unload this flow rate even through the chiller, probably up to like 50%, right? So if you ask me what happens if the load goes less than 50%, yes, then you have to incorporate special controls, probably to fix the flow rate through the pumps and do some bypassing. So eventually, nowadays, you don't see much secondary primary variable, sorry, primary secondary systems. Instead, you can see mostly primary variable systems, which is obviously efficient compared with the primary variable. So with that, I will touch a little bit of energy saving tips, or rather energy efficiency improvement tips, which are again very essential. I'll quickly run through. Supply set point reset. You know, in typical chill water system, we run our chill water supply somewhere like 7 and get the return as 12, if you refer the conventional design. So what will happen if your chiller, if your built-in load is less now, your chill water return is not 12. It will be less than that, maybe 10 or maybe 9, right? So if that return temperature is less than the design point, you can give a program so that it check for like 10-20 minutes and give a automatic reset to the chill water supply set point. Then what will happen? You can understand just by seeing the pH diagram. This was your 7 degrees set point. This is now your reset value, maybe let's say 8 degrees or even 7.5 degrees. Now your chill water supply temperature has increased. Thereby you can see the compressor work now reduces. So your chiller efficiency substantially improved. So automatic supply set point adjustment is something you can look at very smartly, right? So that is something you should look at. Then low approach condenser water. As we were talking in old era buildings, we had the condenser design 32 and 37, right? But instead now we design it for 30 and 35 with the support of good cooling towers, which is possible. So in that case, what happens when my condenser operates at 32 versus 30, you can understand my condenser saturation pressure reduces now. Thereby, my lift has been reduced now, which improves my chiller COP. So that is again you can understand in cooling tower selection. As I told you, if you go for conventional design 32 and 37, 32 minus 27 is the 5 degrees approach we have for the cooling tower. But if you go for 30 and 35 condenser design, 30 minus 27 wet bulb is 3 degrees is the approach. But without any issue, you can select the cooling tower for 3 degrees or even 2.5 degrees. So with that understanding, we can go for 30-35. Actually, when these were initially discussed, there were many refusals, right? But now I can see almost all the designers are following these practices because they give a lot of improvement for the energy COP. So we must follow this. Then high delta T chill water system. Again, it was a big controversial thing in the industry when we were discussing this couple of years back. But now I think almost all the people have understood that, and it is proven in the world. There is nothing to debate on this anymore. So chill water delta T means we were using 712 But if you go for high delta T like 714, 615, whatever it is, you can understand with your fundamentals, your chill water pump power absorption is inversely proportional to the cube of delta T, right? So some case study I have used, if you go for 712, 5 degrees, 714, 7 degrees, this is the scenario. For 712, if you use 20 kilowatt chill water pump, for 714, you can use 7.2 kilowatt chill water pump, more or less 3 times reduce the capacity. That's a huge amount, which you can get the benefit if you go for this nature of work, right? So anyone still doubt on this high delta T, I have elaborated with diagram so that you can understand. Then the use of VFDs, you know, the beauty of VFDs when you use with the motors, if you reduce the speed by 20%, it reduces the power consumption by 50%. Because this is a square law rule, exponential variation. If you unload your VFD chiller, or if you unload your cooling tower fan, or if you unload your HU blower or pump by 20%, you get the saving by 50%. That is a huge saving. Therefore, wherever you can apply, you must think of having these VFD drivers. Then demand control ventilation, because as I told you, to comply the IAQ level, you have to supply fresh air sufficiently and obviously sufficiently. But again, supplying fresh air is a headache because it consumes huge energy to cool this. Therefore, you can see, you can introduce a little bit of controls to adjust the required amount of fresh air that you add in according to the requirement, right? Why do we need fresh air? Is to maintain the CO2 level probably. Let's say now I have designed the system for 100 packs, but now it is at part load. I have, let's say, 10 packs. If I dump the same amount of fresh air, it is an energy wastage. So I control the fresh air amount based on my CO2 level. It's a matter of adding a CO2 sensor and control my blower or the damper with a small control. So you can vary the supply fresh air amount according to the demand. So DCV or demand control ventilation is very smart in terms of energy efficiency. Then variable air volume, you may have a single HU feeding for multiple zones, right? Let's say now in evening at evening in your office, there may be very few people in one cubicle or one section or one zone. There are other zone, there may be no people. So what you can do, rather than adding the same amount of airflow rate through your HU blower, you can vary the airflow rate with the use of VAV controls. It can be a VAV box, it can be a motorized damper based on the temperature. So whatever it is, you can run your HU blower on a VFD rather than running it as CAV. So thereby variable air volumes, you have to think, which will substantially save the energy because it's a square law saving, as I told you before. Then heat reclaim ventilation. Yes, this will also add some of the benefits in terms of energy. If you have continuous exhaust from your conditioned space, rather than just dumping that exhaust, you can use that exhaust air to cool your fresh air to a certain level, right? So that is called heat reclaim ventilation. You can think, let's say if you are having a hotel building, where the hotel room toilets, guest room toilets are continuously discharging or rather extracting. So that air is more or less at room temperature, 24, 25, maximum 26. So rather than dumping it back, you can use a proper system. It can be sort of an enthalpy wheel or a heat exchanger, whatever suitable system can be used to reclaim some amount of that waste energy. So thereby you can cool this supply air at least 1 to 2 degrees maximum. That will be a huge saving if we can achieve. So all these things are applicable, which you can smartly add on to the system. Therefore, as a summary, what I want to convince you is that sometimes in near future, designing an air conditioning system may not be a challenge. The cutting edge or the competitiveness may be designing an air conditioning system at least energy cost, right? Probably tomorrow the bidding challenge or the bid evaluation may be based on kilowatt per ton value of your air conditioning design. If you want to compare the designers, probably that will be the challenge. Therefore, you must understand, you must design the system to comply all the parameters as we discussed so far, but at very less energy, consuming very less energy. So that will be the world tomorrow. To do that, you may have to break some of the barriers, some of the conventional practices. You'll have to think around the world and grab the things what the other countries are doing probably. So example, this high delta T issue, this was there for many years in Singapore. So it infiltrated to us very slowly, but now we are practicing. Likewise, we should bring the things and we should practice things out of the box thinking. All these will give you a sort of a competitiveness to survive in the tomorrow industry. So with that message, I'll conclude the session. Thank you, Ayubowan.
Thank you. Thank you, Engineer Suranga and Sanjay. Can we have this attendance sheet by 9 o'clock so that we can have the attendance to be marked as well? And Engineer Suranga, are you available for some Q&A session? For how long we can have you?
Yeah, you can go ahead for a Q&A as long as I am connected.
Right. Okay. Thanks. Thank you very much, and highly appreciate it. And ladies and gentlemen, as we discussed earlier, the Q&A session goes with, you can raise your hand, and we can see some few hand raised right now as well. So we can raise your hand and we give the priority on first in, first served basis. And please rename yourself. Like for example, I can see somebody from NA / maybe your student's number, but please try to rename yourself. And Sanjay, can we start with the Q&A session? May I start with the Q&A session?
Yeah, I asked one to unmute himself.
All right. Okay. Thank you. We'll start with Populiana Rachi, and ladies and gentlemen, please try to be brief as much as possible. And if somebody have already asked the same question, please don't repeat the question, and please try to make your questions within 1 minute's time. And Engineer Suranga will give you a brief answer. And if it is a time-taking answer, we'll take it a little later, and we can answer you through WhatsApp messages. And if you have any other questions, please write down and put it to the WhatsApp groups. We'll start with Populiana Rachi.
Okay, thank you, sir, giving me this opportunity. My question is, normally the conventional chiller manufacturers, they claim that the magnetic bearing chillers, yes, they are efficiently, there is no doubt, but the durability of that chillers are a little bit less compared to with the conventional chillers because of the speed and number of compressors and so on. So what is the experience on that?
Yes, there is a validity on that claim because these are fast machines, wear and tear is very high. But I think in the industry we have been dealing with for last 10 years. Like it is too early for us to comment in terms of local expertise. But what I feel it in the different angle, even though if you want to discard it maybe few years before the conventional chillers, you would have saved that amount of money because of the efficiency. So that is where you need to think about the life cycle costing before you make a decision. So what I feel is even though they have a little less age, obviously within that age they may have reached the capex expenditure. So you have money to go for another chiller because that has been saved already.
Okay, thanks. Rukman Hemachandra, please. You can raise your question.
මට දැනගන්න ඕන රෙෆ්‍රිජරන්ට් එක වෙනස් වෙද්දි අපි අර ප්‍රෙෂර් එක චෙක් කරන්න ඕනනේ මේකට ගහන යුනිට් එකට ගහන ප්‍රෙෂර් එක තියෙන රෙෆ්‍රිජරන්ට් එකේ ඒ ප්‍රෙෂර් රේන්ජ් එක අපිට බලා ගන්න පුළුවන් තරක් තියනවද? ඒ කියන්නේ මොකක් හරි ස්ටෑන්ඩඩ් එක හරි මොකක් හරි සඳහනක් තියනවද කියලා තමයි මට දැනගන්න ඕන. ඕවර් ප්‍රෙෂර්ද ලෝ ප්‍රෙෂර්ද කියලා බලා ගන්න.
ඒ කියන්නේ රෙෆ්‍රිජරන්ට් එකක ඔපරේටින් pH diagram එකක් තියෙනවා. ඒතර pH diagram එකෙන් අපිට පුළුවන් මේ රෙෆ්‍රිජරන්ට් එකේ ඔපරේටින් ප්‍රෙෂර් එක මොකක්ද කියලා බලා ගන්න. එතකොට ඒකට පොඩි added support එකක් ගන්න පුළුවන් manufacturers catalog එකෙන්. catalog කියන්නේ ඇත්තට මේ අදාළ product එකේ ඔයා refer කරන්න ඕනේ normal catalog එක නෙමෙයි. there is something called engineering manual. ඒතර ඒකේ අනිවාර්යයෙන්ම තියෙනවා ඔයා unit එකට කොච්චර high side pressure කරන්න ඕනද low side pressure කරන්න ඕනද කියන ඔක්කොම. but ඒක fundamental තත්ත්වයට ගිහලා බැලුවොත් ඔයාලට basically refrigerant එකේ property diagrams තියෙනවා charts තියෙනවා. ඒකත් එක තමයි හොයාගන්න වෙන්නේ ගොඩක් වෙලාවට.
Thank you, Engineer Suranga. And now, anybody you have any language barriers, you can use any language, either language you can ask a question. We'll go with Vijita Mahasen.
Yeah, thank you for giving me this opportunity. Yeah, so I'm working in an apparel sector, and in our factory we are using the magnetic bearing chillers. So my question is, we are using it for around 7 years, but the main issue is we are operating it with the PFR release. So when there is a power failure or power imbalance, the system will go totally down, and then we need to restart. And this system is normally synchronized with the BMS system also. So what are the things we can do to minimize this issue?
That is something you need to look at about the electrical system, I feel, because if you get frequent tripping or failures, that first you have to address about the electrical system. I don't see any possibility to cope up with the chiller side, because anyway chiller has its own like shutting down safety features, mechanisms, etc., regenerative brakings, etc. But the as I feel your explanation is directly connected with the electrical system, which obviously had to look at. That's what I see with this explanation.
Okay, sir. Thank you.
Yeah.
Thank you. And can I go with Madhusanka or Madhusanka?
thank you sir මේ opportunity එක දුන්නට මට දැනගන්න ඕන sir ලංකාවේ තියේද මේ HVAC design engineer කෙනෙක් වෙන්න ඒ A to Z ඉගෙන ගන්න ආයතන හරි ඒ මොනවා හරි දේවල් තියේද ඊට පස්සේ ඒ A to Z ඉගෙන ගන්න මොනවා හරි recommend කරන පොත් තියේද design engineer කෙනෙක් වෙන්න HVAC ඔයාලා ළඟ ඒ කියන්නේ දන්න ඒ පොඩක් මට ගැන තමයි දැනගන්න ඕන.
ඔයාගේ background එක මොකක්ද කියලා හෙවුවොත්
mechanical that කරන්නේ මේ HVAC කරන්නේ site engineer කෙනෙක් assistant කෙනෙක්.
right, okay, right. මේමයි ඇත්තටම HVAC කියන්නේ ගොඩක් fundamental knowledge එකක් ඕන subject එකක්. ඒතර ආගේ basic subject touch එක අනිවාර්යයෙන්ම තියෙන්න ඕනේ. ඒකත් එක්ක application. ඒ කියන්නේ ඕක දෙකක් තියෙනවා, theoretical subjects, applications පැත්ත. ඒ application ටික ඔයාලට පුළුවන් standards, codes, guide books ඒ වගේ පොත් refer කරලා ගන්න. but අර theoretical aspects ටික ඔයා මොකක් හරි program එකක් through කරගන්න ඕනේ. ඉතින් ගොඩාක් programs තියෙනවා, මට එහෙම specially දැනට කියන්න බෑ. අවශ්‍ය නම් අපිට පුළුවන් ඒකට help කරන්න, මේ recommendations ටිකක් දෙන්න ඔයාට ඉස්සරහට යන විදිය ගැන. ඒක අපි specifically address කරන්න පුළුවන් ඔයාට open නැතුව.
සර්ට මට ඔය කියන්නේ number එකක් තියෙද මොකක් හරි
ඔව් මගේ contacts ටික ගන්න පුළුවන් වෙයි. ඒකෙන් මට ඔයා mail එකක් වගේ දැම්මොත් මට පොඩි guidance එකක් දෙන්න පුළුවන්.
හරි okay sir, thank you.
Yeah.
Thank you, Engineer Suranga. And can you go with Dilrukshi Prasangika?
sir මේ අර දැන් කිව්වේ chillers වල secondary pump system එකක් නැහැ දැන් ගොඩක් වෙලාවට. එතකොට මේ මට දැනගන්න ඕනේ කොහොමද ඒ කියන්නේ pressure කරගන්න කොච්චර දුරකට ඒක pressure කරන්න පුළුවන්ද chill water line එක. නැත්නම් අපි කොහොමද ඒක initial design කරන්නේ pressure කොච්චර pressure එකක් තියනවද කියලා.
pressure එක කියන එක මම පැහැදිලි නෑ. මොකද pressure කියලා mean කරන්නේ?
primary secondary system එකක් තිබුණා නම් අපිට දැන් AC එක ළඟට AC එක තියෙන දුර මත ඒක තීරණය කරන්න පුළුවන් pressure වෙන pressure එතකොට
නෑ මෙහෙමයි දැන් ඔයා secondary pump එකේ pressure එක කියන්නේ pump head එකනේ. ඒක pump head එක size කරද්දී ඔයා primary secondary system එකේ secondary pump එක size කරන විදියක් තියෙනවානේ. total pipe length එක අරගෙන fitting loss එක අරගෙන ඊට පස්සේ coil loss එක ඔය ඔක්කොම ටික එකතු කරලානේ ඔයා size කරන්නේ head secondary pump එක. ඊට අමතරව primary variable වෙද්දී ඔයාට තව add වෙනවා basically chiller එකේ chiller coil load එක. ඒ කියන්නේ chiller එකේ tube හරහා යන loss එක. එතන මීටර් 3ක් හෝ 4ක් ඇඩ් වෙයි තව. එතකොට ඒ ලූප් එකේ යන ටෝටල් හෙඩ් එක ඇඩ් කරාට පස්සේ හරි වෙනසක් නැහැ. අරක මෙතඩ් එකම තමයි යන්නේ. එම ප්‍රෙෂර් ලිමිටේෂන් කියලා තියෙන්නේ ඇත්තටම දැන් අපි ගොඩාක් හයි රයිස් බිල්ඩින් එකක වගේ යනවා නම් අපිට චිලර් එකේ ප්‍රෙෂර් එක ගොඩක් එක්සීඩ් කරන්න බෑ. මොකද ඒක ප්‍රෙෂර් රේටින් එකක් තියෙනවා. ඒ වගේ වෙලාවකට අපිට පුළුවන් ගොඩාක් කොයි තට්ටු 40 50 බිල්ඩින් එකකට චිල් වෝටර් පම්ප් කරනවා. අපි කරන්නේ මැද හරිය අපි දාගන්නවා හීට් එක්ස්චේන්ජර් එකක්. එතකොට පහළ සෝන් එකේ ප්‍රෙෂර් එක විතරයි චිලර් සයිඩ් එකට ඇප්ලයි වෙන්නේ. බට අදහස් කරේ ඒක නෙමෙයි මට තේරිච්ච විදිහට පම්ප් හෙඩ් එක ගන්න විදිය. හෙඩ් එක අපිට ගන්න තියෙන්නේ බේසික් අර විදිහටම තමයි. ඒක ලොකු අලුත් දෙයක් නෑ.
ඔව් එහෙනම් මම කියන්නේ සෙකන්ඩරි පම්ප් සෙට් එකක් නැත්නම් එතකොට කොහොමද ඒක
ඒ කියන්නේ එතකොට වෙන්නේ වගේ සෙකන්ඩරි පම්ප් හෙඩ් එක කැල්කියුලේට් කරා කියලා හිතන්නකො ඉස්සෙල්ලා විදියට. දැන් අලුත් ප්‍රයිමරි වේරියබල් වෙනකොට ඒ සෙකන්ඩරි පම්ප් එකේ හෙඩ් එකට ඇඩ් කරගෙන යන්න තියෙන්නේ basically ඔයාගේ primary side එකේ තිබිච්ච load එක. primary side එකේ load එක කියන්නේ ඉස්සෙල්ලා primary pump එක size කර විදියනේ. ඒ head එකනේ. ඒතර ඇත්තටම මේ head එකේ එකතුව තමයි දැන් primary variable pump එකේ total head එක වෙන්නේ. තේරුණාද?
ඔව් හරි. thank you sir.
ඒ කියන්නේ ඔයාට මොනවා හරි doubt එකක් තියෙනවා නම් ඔයා මට ඒ කියන්නේ specifically refer කරන්න. ඒක මේ එතෙන්දී මේව කරලා දෙන්න පුළුවන්.
හරි. thank you sir.
Thank you. We'll go with Ruan Pereira.
Yeah, I just wanted to ask, actually this is not related to the subject matter. Actually, last time also I participated 2 meetings, Zoom meetings, but I couldn't, you know, that mark the attendance in Google Sheet.
So we lost him or what?
Line is not clear to me.
Yeah, I think we lost him. Sanjay will put the attendance marking sheet. There were a lot of requests. I think we can see a lot of participants here. Ladies and gentlemen, we only use this attendance sheet through chat box only, and this Zoom platform as well as in the YouTube platform. We'll put in the chat box, and those who couldn't mark your attendance due to some technical failures, we give one opportunity just after the session. The organizing committee will share one Google form again with your details, plus you have to keep certain screenshots where you have to upload those screenshots. And we have another participant with the name of Dell. I asked him to rename. I think that is Ravindra Sampath. Ravindra Sampath, it's for you to ask a question.
Yes, good evening, sir. Can I know whether is there a specific software for the cooling load estimation, especially, you know, actually accepted specific software platform that may be easy.
Yeah, there are many softwares being used in the industry. There are HVAC. There is one called HVAC. There is another called Carmel. There is another called IES. I think that's a commercial software. Then Carrier HAP software, which is been popularly used in the country. And there are set of softwares. But the thing is, you have to see whether it is proven in the industry, because what it gives is the final decision, right? So you have to use a proven software. All what I said are more or less been used in the industry for last many years. So you can use one of those softwares.
Could I know?
Mr. Suranga, I think
they
need to repeat the names, please. Engineer Suranga, we will get those things and we will put into the WhatsApp groups. Don't worry.
Yeah.
Engineer Suranga, please give us a list. Then we will share, and there are some
Nice.
free downloads
Thank you
as
very
well. So we'll share in the WhatsApp groups. Please be in touch with those
Yes,
WhatsApp
we will do.
groups.
Yeah, thank you,
yeah.
sir.
Okay, thank you. And Rupan Hemachandra.
මට තව එක ප්‍රශ්නයක් ගන්න මේ ඉන්වර්ටර් ටයිප් AC වල අවුට්ඩෝර් යුනිට් එක අර පැනල් එක පොඩ්ඩක් එක්ස්පෙන්සිව් කිව්වනේ මේ PCB එක. එතකොට අර සීසයිඩ් ඒරියා වලට දාදි මොකක් හරි ස්ප්‍රේ එකක් තියෙනවද රෙකමන්ඩ් කරන පැනල් එක ප්‍රොටෙක්ට්
එහෙමයි
කරන්න?
එතන ෆින්ස් වලට කොහොමත් අපිට කෝටින් එකකට යන්න පුළුවන්. PCBs වලට අර kind of a lamination එකක් propose කරනවා වැක්සින් වගේ proposal එකක්. එතකොට ගොඩක් වෙලාවට ඒකේ පොඩි repercussion එකක් තියෙනවා. මොකද heat dissipation එක යම් කිසි දුරකට compromise වෙනවා ඒක කරාම. but අර salt එක ඇවිල්ලා touch වෙන්නේ නැහැ. එතකොට ওই circuit වල soldering වගේ issues එන්නේ නැහැ. ඒ වගේ දෙයක් තමයි ගොඩක් වෙලාවට කරන්නේ. වැක්සින් lamination වගේ දෙයක් තමයි PCBs වලට කරන්නේ.
Thank you. I think we have one of our very good friend Eranga Vitanage is available.
Yeah, Mr. Engineer Suranga, Engineer Nalin, thank you very much for giving me the opportunity. Can I audible to you?
Please, yeah, go ahead. Yeah.
Yeah. Engineer Suranga, thank you very much for valuable lesson. I have one question regarding split air conditioning system versus VRF system. Actually, I'm joining to the session from Dubai. There's a kind of a huge debate. What is the PCable system for villa type of a project, whether to go for a VRF system or to split system? I'm not sure that whether you have done such a case study, but I want your opinion on that in the first. And the second one regarding the LCC life cycle costing. I have heard that split air conditioning compressors should be replaced in 10 years, whereas VRF can be run as 20 years. With your experience, and could you please advise on these two phenomena, Engineer Suranga?
Heranga, yes, thank you. Thank you. Mr. Suranga, I think for your clarification, maybe Heranga is referring a villa, not like a villa in Maldives, like, but the villa in Middle East is something like a 2-3 floor, 1 unit of a house for maybe one rich person can handle. Is that the concept Heranga you refer?
That's correct, Nalin. That's correct. Like it would be a 500-600 set of villa with G+2.
Yes.
Kind of like with 3 or 4 bedrooms in one villa.
Yes, 1 unit. Yes.
Yeah, correct. That's true, Nalin. Yeah.
Okay, just to answer that one, there are a few things to be looked at. When you go for a VRF system, there is sort of a single system, maybe with a single ref circuit. Your reliability is somewhat compromised. If there is a leak in one unit, your whole system may have an effect. But that is not there if you go for single splits. But in contrast to that, your aesthetic is somewhat compromised if you go for multiple outdoors, because split system, obviously you have to hang somewhere or you have to place somewhere. So that will be the issue. But in addition to that, energy, if it is an issue, you have to obviously go for VRF systems. But very critically, in luxury, the level of luxury, if I looked at VRF, sometimes given a noisy expansion, since the expansion device is in indoor. So if you have a concern on that, probably single split may work better. So all you have to think together and make the decision, not just a single parameter. But regarding the life of compressors, what I have experienced is typically 5 to 7 will rely for like split small compressors. But VRF I have seen more than 10 years running without any issue. But all subjective. But typically, when your compressor getting bigger, its lifespan is bigger. That is the very simple understanding. Therefore, definitely split versus VRF will give better lifespan of your compressor. At very first cut, I can say. Yeah.
Thank you, Engineer Suranga. And Heranga, you have anything to add on this? So, you have any further clarification? You're muted, Heranga.
Yeah. That's fine, Nalin. That it will be clear actually. Now, I have done one exercise. Still, it is in the debatable, gray area. most of the consultant, sometimes client challenging, but whatever the engineer Suranga explained it, it's like gives me some confidence. Thank you very much, both of you. Thanks.
Thank you. Thank you. Ladies and gentlemen, I think we are done with the hand raise, and we have another message from the organizing committee. Please mark your attendance because that is compulsory to earn your certificate. Please mark your attendance, and Sanjay, we have put again the attendance sheet, right, in the chat box.
Yeah.
All right. Okay. Thank you very much. And we have Tushar. We have Nadini Ratnayak. Another hand raise. We can go for 1 or 2 questions. Nadini Ratnayak.
Sir, I have one question. I am an architect. So after all installations, before the handing over procedure, we have to do testing and commissioning partners. So in this point, how we can check AC capacity before we confirm that it has installed properly? Just for the knowledge,
I think you will understand. Your question is clear. I think you will get a very comprehensive clarification on your 4th session, I think, Nalin, because there you will be discussing AC. But just to give a specific answer for your specific question, if it is a chiller, you have to find the delivered capacity. You can measure the flow rate with the clamp on flow meter. You can measure the differential temperature, supply and return. Then you apply it on your MC delta T basic equation. You can calculate the tonnage output. But the question is that at the commissioning time, your building is not loaded. It will be loaded maybe up to 30-40%. So you can check only that figure. If you want to do that, you have to add dummy loads, but that never happened in anywhere in the building. So existing load you can measure in that basis. Yes.
Thank you. Thank you, Surang, and thank you, Nadini, as well. And Engineer Surang, if I want to go a little bit further, because I've seen in many, again, debatable points, and sometimes in the specifications also it's mentioned, third party verification or something like once you have a design and once these, especially in the bigger projects, like I could remember in airport development project back in 2007, there was a special request from by the specification itself, there should be some third-party verification of the design and the installation. So how it happens and how it works in Sri Lankan context, like.
Yeah, that is a good question, Nalin, because it has 2 parts. Third-party review, or rather, it's known as peer review. Some people say it as value engineering review, but whatever it is, having a third eye on one's design is always good, because you can see it in terms of design aspects, in terms of energy efficiency aspects, in terms of value engineering aspects. Therefore, having third eye is always good, because any human being can make errors. So that is good. Number 2, when it comes to the testing and commissioning, I think that is a must. Even in Sri Lanka, we should have third-party T&C, because when you design and if there is something wrong at the commissioning, the consultant never disclose that. He need to hide it, because the problem will come to him in that case. Therefore, we find many issues which are hidden inside the CD sometimes. So if you bring the third-party T&C team, which is happening in all the countries in the region like Singapore, it is a must probably, obviously. So they will come and do their job. So they will try to find some errors or other faults. So that will make your design improved. Therefore, I think that third-party T&C we must bring into here, and we must emphasize to practice that. That will add a big value. That's the answer I can share with you.
Right. Thank you. Thank you, Mr. Rangan. We have about 5-10 minutes, and if you wouldn't mind, just can you elaborate a little bit about this ventilation part also, because especially the car park ventilation and this sometimes the staircase pressurization, those are also play a vital role in especially in the high-rise buildings. And if you can just quickly glance through, maybe like taking 2-3 minutes, and what are the best practices once you design those ventilation systems, that would be grateful, I think.
Yeah, because when the 2 scenarios that you explained, pressurization and car park extraction, that is not a choice, that is a must. because in terms of fire, you are compelled to do that. When it comes to the pressurization, because you need to make a smoke-free escape for people when there is a fire. So you must design it with high reliable system. You have to control the pressure without exceeding. There are certain things to be looked at. Then when it comes to the car parks, especially if it is a basement car park, so you add in a lot of smoke if there is a fire which is entrapped. Even there is no fire, there is a high chance of making fire in basements, car parks, because the ambient is very high in temperature, as well as your vehicles are storing high flammable liquid like petrol, etc. Therefore, you need to make a comfortable environment even there is no fire. That's why you are forced to have a ventilation system for basement car parks, which should run 24/7, right? At the same time, if there is a fire, you can use the same extraction system to take the smoke out, but at little higher rate. So all these need to be looked at when you design a system. But the main question in basement is that when you want to design an extraction system that need big ducts, huge ducts, but there is no sufficient room height for you to install them. If you have been to a basement, you can see those are very, very narrow in height. So in that case, we have a choice to go with like a jet fan system, as you can see in many of the new developments in Sri Lanka, where you don't need duct. You don't need the ducts. It's a ductless system where you can see fans to extract smoke without the ducting system. So those are the trends in the sector, but it is something which you need to do properly, as well as I advise you to verify that before installation with the use of CFDs. That is a must, right? So all these new things to be looked at, especially on fire related aspects like pressurization and extraction. That is important.
Right. Thank you very much, and that's a great answer. And ladies and gentlemen, another reminder to mark your attendance again, and we will go for the final question. Again, I think Ravindra Sampath will go with this might be the final question in the Suranga. Apology for any this.
That's fine.
Yes, please go ahead.
Further to the previous question, is there a particular software platform for the calculation of the static pressure drop calculations in the exhaust or any other supply air duct system, or sometimes in the fire mode cases in the areas where some smoke should be exhausted. Is there some sort normally Excel is the method, Excel files are used to calculate the pressure drops. So in any software platform to determine the pressure drops.
I think it means about the ventilation software, I think.
Yes.
Yeah, true. What he's asking is to calculate the ESP of the ductwork. When you do it in manually through spreadsheets, that is a messy process. I do agree, but you know, there are softwares which are really commercial softwares. In addition to that, there are some proprietary softwares developed by the fan manufacturers which you cannot perfectly trust on. Therefore, sorry, I have no names in me for the moment to tell you about the commercial softwares. But even if you go for like BIM modeling, like if you use Revit, I think they have an inbuilt feature for you to calculate the ESP. So when you move to the BIM platform, definitely there will be a facility. In addition to that, there may be, if you're interested, I can find and share with you later.
Okay, thank you.
Yes,
thanks.
And, thank you. And Engineer Suranga, please share with us the list of maybe I think with this new generation are quite fancy of having these softwares. Therefore, let's have a list of softwares for air conditioning as well as the ventilation. With that, ladies and gentlemen, we are almost at the end of the session, and we are like 9:20, which is about 2 hours spending time with Engineer Suranga. And again, special thanks to Engineer Suranga with your vast knowledge of experience, especially in the design segments. And I agree with you that we don't have enough time to go with all the calculations. With that, it's still that you have, I'm sure that you have done a justification to the time, and as well as the audience. We had around over 1,000 participants through Zoom as well as in the YouTube platform. And Engineer Suranga, do you have any final message just to give this, especially there are a lot of undergraduates. Number one is about the design aspects, and the number two is this continuous professional development of the CPD sessions. And finally, if you can add something about this challenging environment in the future, so how especially the young and these engineers are facing and contributing to this situation. So Ranveer.
Yeah. Actually, that is, I am very happy to share some of the thoughts with you, especially with the youngsters who are willing to get into the sector. I know it is a bad time for you to enter the industry where the industry is getting squeezed. But what you have to do is, I think this time you should invest for something. Invest in the sense you must spend time to gather knowledge probably. So this kind of sessions, I think we must thank for organizing, especially free, right? Because one of my Australian friends said that why Sri Lankan people are so much sharing knowledge at free. He said, if I do it here, I will charge much per hour. So he said, you all are doing a really valuable thing for your next generation. This is one of such. So I'm happily contributed. You spend time to make your cutting edges. What I simply say is, now you should sharpen your sword, right? Or you should load your guns. When the war starts, you have no time to do that. You can keep fighting. So this is the time for you to make that. I don't think that it will this turbulent in the industry will exist multiple years. I don't think so. Therefore, that is number one. Number two, for you to be an expert on the sector, firstly, you must thorough on your fundamentals. This is a repetitive message which I happily give to the youngsters. We see some of the very aged people sometimes very much lack of fundamentals. So you can't rely in a computer environment. But if you are thorough on your fundamentals, you can sort any issue, even at site issue. If you just think and recall your theories, you can get a solution. So you must be smart on your fundamentals. Again, be vigilant what is happening in the world. Open to the world, because now all the platforms are connected. You can be a global living being. So be open. Read the new stuffs. Example, I think Engineer Nalin will agree with me. If you see some of the today's project specification, the standards people are writing is outdated, right? Sometimes they have been withdrawn in 70s, but still we are referring those old numbers for standards. That is simply because we don't go in line with the world. So there you can't rely. Probably the last few decades that would be okay, but in the time to come, it will be really challenging. There may be a lot of foreign interventions for you to become a competitive person in the sector. You should sharpen all your things. Thirdly, you must be smart on your soft skills, the way you communicate, right? Communication is not the language. The way you talk, how confidently you talk, eye contact. I think Engineer Nalin can add many things onto that. So that is another thing which I feel lack, because our engineers are not much talkative. Sometimes when you sit in the table, the other professionals are dominating the table. If you are not talking in the sense not like parrot, but you must talk with facts and figures, then only people will listen and people will respect you. So those are the things that I think as youngsters you must develop. At last you must have the confidence on you. That is the number one bullet I can tell you about my success. I was really confident about myself wherever I am, right? Whether I am correct or not. So that is again something important. We see sometimes people answer doubtfully. That because you are not sound on your answer. So you have to be confident on you first. All these will add you a spectrum of colors onto you. Again, one more thing, don't just focus on to one stream. Professional life is only a single thing. Do all the other things, do music, do dancing, do arts, whatever it is, right? That will add different colors into a spectrum. So finally use all your talents to make a brand. That's not the message. Thank you.
Thank you, Engineer Surang. And yes, we have seen you with these multiple activities and you're a multiplayer. I have seen personally, and yes, as you well mentioned about that, the future is challenging, so that we have to work sharply. And I would love to highlight the statement you mentioned that let's sharpen our arsenals and the weapons and get ready for the war. And when the war starts, at the very instant, we can keep on shooting. With that message, ladies and gentlemen, I would like to again thank you very much, and it's an honor, Engineer Suranga, being with us and with your vast knowledge, and you were selfless to share those wealth of knowledge. And thank you very much again for being with us on a Sunday evening. Otherwise, you would have spent the time with your family and with your guitar, I'm sure. And thanks a lot, ladies and gentlemen. It was a pleasure to have one of our charming gentlemen to sharing knowledge, and I'm sure that he will be in touch with us. And I would like to invite you all as well to be in touch with our WhatsApp groups and our communication protocols, where we can share our knowledge and we can share opportunities, and especially for the future. And if it is a challenging time, it's all about making our strength as a good network. As Suranga highlighted, may not be just like in Australia, but Sri Lankan culture is different. So let's cherish our culture and let's cherish our strengths together, so that I'm sure that the challenges are not and inevitable, but still we can face with a good heart. With that remark, ladies and gentlemen, again, thank you very much for you being a nice audience. At the same time, I would like to thank our organizing committee, works behind the screen tirelessly and giving you all these opportunities and facilitating. Thanks a lot and have a pleasant evening. Good night.
Bye.